In this example, we're going to solve a radical equation that has two square roots in it. What we want to do first, if we notice that there are two square roots, is to isolate one root on one side of our equation. Since that's already done for us, we can go ahead and square both sides to remove this first square root. Remember that when you square both sides, you have to square the entire side. So that means over here on the right, we're going to have square root of x plus 3 all to the power of 2. The left-hand side is going to simplify to 3x plus 1 because the action of squaring is going to undo the action of taking the square root. Over on the right-hand side, we can rewrite this as root x plus 3 times root x plus 3 and expand this out to simplify. Expanding through the brackets on the right-hand side, when we multiply our first two terms together, we're going to get root x times root x. And this simplifies simply to x. When we multiply our two outside terms, we get 3 times root x. And when we multiply our two inside terms, we also get 3 times root x. We can group these together into 6 root x. And then finally, the two last terms, 3 and 3, when multiplied together, are going to give us a value of 9. So here's our fully simplified right-hand side. Notice that we still have a square root in our equation. So our next goal is to try to isolate this square root on the right-hand side. So I'm going to move the x and the 9 over to the left-hand side. Doing this gives us 2x minus 8 is equal to 6 times the square root of x. Now we could isolate this root by dividing by 6, but that's going to cause us fractions. So why don't we just square both sides right now as they are? So remember that our left-hand side is going to become 2x minus 8 times 2x minus 8. On the right-hand side, we're going to have to distribute the square operation through to both of the pieces on the inside. So that means we're going to get 6 squared, which is 36, and then root x squared, which is x. So let's go ahead and expand through the left-hand side. Notice now that we have a quadratic equation. So let's get this into standard form and see if we can factor this to simplify. So I've done a couple steps here. I've collected the two negative 16x's and made them a negative 32, and then I subtracted 36x from both sides, and that's going to give us 4x squared minus 68x plus 64. Now I notice here that all of my numerical terms have a common factor of 4, so I'm going to pull that out first. And that's going to make this quadratic much easier to factor. So looking for two numbers that multiply to give us 16 and add to give us negative 17, those two numbers must be negative 16 and negative 1. This tells us that x minus 16 is equal to 0, or that x is equal to 16, or x minus 1 is equal to 0, and that x is equal to 1. So here are our two possible solutions to the original equation. Just like we did before, we should double check both of these answers, as squaring both sides may create new solutions that won't be solutions to our original equation. So let's begin with x is equal to 16. If we make a substitution of 16, we're going to get 48 plus 1. And over on the right-hand side, we'll get root 16 plus 3. Now the right-hand side simplifies to 4 plus 3, which is 7. And over on the left-hand side, we see that this is square root of 49, which is equal to 7. So 16 is a solution to the original equation. Next, let's try substituting x is equal to 1 into the original equation. If we sub in 1, the left-hand side gives us square root of 4, which is equal to 2. And the right-hand side gives us square root of 1, which is 1, plus 3, which is 4. So our right-hand side and left-hand side are not equal in this case, so we can't take x equals to 1 as a solution to our original equation.